guys, it's Mrs. Spiro. Let's see if I can get that a little darker. There we go. Sun is streaming into my classroom. Okay. So now we're talking almost like the opposites of what we were doing yesterday. And I'm looking for my glasses again. So let's go through these. So if you have two pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Yesterday it was all about the parallelogram was a quadrilateral. Now it's kind of the opposite. So if you have opposite sides that are congruent, then this quadrilateral is a parallelogram. So AB goes with DC. Same thing here. So this is sides. Kind of like to do that. Kind of draws your eyes. This is angles. So if two pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So angle A and C to go together in B and angle D. If your diagonals, I'm going to write this on the side, diagonal, bisect each other, then the quadrilateral is a parallelogram. So you can see when they do that, I don't think your picture yesterday was as good, but this is showing you that A, there's no point here. From here to here is the same as here to here. Here to here is the same as here to here. So AC and DB intersect. Actually, they call it bisect. There we go. Okay, this one here. If one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So the parallel sides here. So AB is parallel to DC, therefore AB is congruent with DC. Okay. What is that? Parallel, parallel. I love the word parallel has a set of parallel lines in it. Awesome. Okay, so is this a parallelogram? Yes. Because of the opposite, we have 35 is equal to 35, and those are opposite sides. So that has to do with sides. So that's theorem 6.9, which is opposite sides. That one was easy. I think this one's going to be pretty easy. You probably cringe every time you see this, but let's take a look at this. Okay, so go ahead and plot your points. And label. Again, I really should use a straight edge. Oops. This is Spiro. I forgot one. -2, -1. Here's my T. We'll just add him here. Look at us. There he is. All right, determine whether the quadrilateral is a parallelogram. Can't really do angles, so we're going to go back to the sides. And how can we measure those sides? It says to use the slope formula. So from T to Q, we'll do T to Q. Is it equal to SR? That's what we're claiming. So T to Q, it would be the same thing as finding the Pythagorean theorem. So that's 1, 2, 3, 4 over 1. So up 4 over 1. How about S to R? Up 4. 1, 2, 3, 4 over 1. They are equal to each other. So let's try the other one. We could do the other side, just for fun. So does QR equal TS? So I'm going to have to go, I always like to rise. You guys can do it however you want, but I'm going up 1, 2, 1, 2, 3, 4. I went up to -4. And then this one I'm going up to 1, 2, 3, 4. Same thing. Up to -4. And they are equal. So yes. Sides definition of a parallelogram. I kind of cheated there. It's all right. You have it here. Why would you put in the slope formula, which is the y2 minus y1 over x2 minus x1? But you can. That's what you want to do. All right, so let's find x and y. So the quadrilateral is a parallelogram. So we should know that these two would be equal to each other and that these two would be equal to each other. So I'm just going to mark those because I'm saying that those are equal to each other. So 4x minus 1 is equal to 3 times x plus 2. And solve. This is the fun part. Minus 3 plus 1 minus 3x. X is equal to 7. Okay, so x equals 7. Let's find y. Obviously, these two are equal to each other is what we're saying. So 3y plus 3, I'm going to go ahead and distribute. It's equal to 4y minus 2. Subtract 3y, add 2, gone 5, y equals 5. So it just said to find x and y. So we do not have to plug these back yet. Okay, but always pay attention to that. Okay, so down here, so to prove, this is kind of like a summary. So show that both pairs of opposite sides are parallel. That's a definition. Both pair of opposite sides are congruent. That's the 6.9. Show that both pairs of opposite sides are, opposite angles are congruent. That was 610. Show the diagonals bisect each other. That was 611. And show that a pair of opposite sides is both parallel and congruent is 612. So that's both. All right. This wasn't so bad. Well, let's go to the next one. I think you'll like this one too. Finally, right? A little bit of break. So you guys should already know the areas of a parallelogram and triangles. So a parallelogram is a quadrilateral. And so the area of a parallelogram is, oh, it's down here. Sorry, I don't have to do that. Do you have a triangle? Yeah. So the angle is the inside. I'm sorry, the area is the inside. Actually, I want to say like the cover. I think of it as wrapping paper. Okay, so area of a parallelogram, so it's base times height. Some people call it length times width. They usually use that with a three-dimensional. Always, your base and height always forms this 90 degrees. So this is the key right here. So this is your B, kind of looks like a B, and it looks like an H. So this is how you always know your base and height. Must have that to find your base and height. Area congruence. If two figures are congruent, they have the same area. Some of these it's like no duh. Area of a triangle. So let's go back up here and kind of make sure you know that. I'm thinking you know that up there. And I think you know the area of a triangle. 1/2 base times height. Some people do base times height times 2. And of course, Mrs. Sparrow does 0.5 base times height. So all the same thing. Again, you have to have this guy here to find your base and height. Have to look like, always looking for that perpendicular to find a base and height. Perpendicular, that is the key. Okay, it doesn't say how to find perimeter, but let's put that in here. Perimeter. It's your rim, and that's your sides all added up. Okay, just so you remember. So find the perimeter here. So if we are saying that this is 12, are we saying of this parallelogram? Okay, so this is 20, this is 20, this whole thing is 32. So let's just add those up. Hopefully you have your calculators. So my perimeter is equal to 32 times 2, I have 2 of those, plus 20 times 2. Again, solve it how you need to. Inches. Okay. To find your height. How are you going to find your height? Right here. Because A equals base times height, and we don't have your height. How do you think you could find it? Hopefully, you don't think that this is your height. Your height is always this. I can't stress that enough. So hopefully you're looking at that and going, hey, that's a right triangle. I can use the Pythagorean theorem. This is Sparrow's favorite. So I know that this is an A, this could be my B, and this is my C. I know this is my C because it's my hypotenuse. You guys should always know. Some of you are still struggling with the Pythagorean theorem. The hypotenuse is opposite of this right angle. So this is a right angle as well. Hypotenuse is always opposite of that. It's the largest side. So over here, I'm going to say 12 squared plus b squared equals 20 squared. I'm going to subtract 12 squared from both sides. As you can see, I'm taking a shortcut. So in my calculator, I am going 20 squared minus 12 squared, and that gives me 256. Taking the square root of 256. So clear, second, square root, opposite of squared, 256 is 16. So B equals 16. Wow, you couldn't see any of that. There we go. Oh, so there we go. So now we have our base of 32. and my height of 16. 32 times 16 gives me 512 inches squared. Because we are multiplying base times height, it's a two-dimensional figure, so it's squared. It's how many squares, literally, how many squares are inside of this baby? Okay, moving on to this one. Find the area of PQRS. Okay, so the same thing. So my base here is 12 from here to here plus 3. So this whole thing I'm thinking is 15. Now, I'm thinking the way they've got this is 9, 9. Again, we need to find our height, and we know this part is 3. So we'll have to do what we did before. So 3 squared plus, I'll put h squared for height, equals 9 squared. So 3 squared is 9, so I'm going to subtract 3 squared. I'm sorry, I was just thinking of something else. So h squared is equal to 9 squared minus 3 squared. 9 squared minus 3 squared gives me 72. So my height is the square root of 72. It's a perfect, it is not a perfect square, so what we're going to do is, I kind of want to, let's see what we get when we do that. So second square root of 72, is it something? Let's go ahead and round that to the nearest tenth, 8.5. And I'm going to put my ziggity-zaggities here, so we know we rounded. Okay, so my base is 12. My height is 8.5. Times 12. 102. Units squared. Okay, the other way you really could have done this is saying 12 times the square root of 72. So I'm just going to leave both of those just so you can see that. This would be more of an exact answer. What goes into 72? 9 times 8. There's perfect squares in there. Okay, we're just going to move on. Okay, don't get too technical, Mrs. Spiro. Okay, so here you need to buy enough boards to make the frame. So we're making a frame here of the sandbox. What a very strange sandbox. And enough sand to fill it. So you need to find that rim, right? So boards to find the rim. So we need perimeter, 16 plus 7.5 plus 12. How many boards? 16 plus 7.5 plus 12. At least 35.5 feet. If one board is 3 feet and one bag of sand fills 9 square feet of sand, how many boards and bags do you need to buy? Okay, so we need to divide this by 3, right? So we need to buy about 12 boards. All right, so that one was okay. This one is area is 1/2 base times height. So A equals 1/2. Now see, you've got, this is our height. So our height is way over here because we're looking for this perpendicularity. So 12 0.5, my base is 12, and my height is actually 9. What's half of 12? 6. 6 times 9 is 54. And one bag of sand fills 9 square feet. So this is units squared. How many times does 9 go into 54? 6 bags. All right, that was fun. All right, let's take a look at this. The height of a triangle is 7 inches. So we've got a triangle here. The height of a triangle is 7 inches more than the base. So here's my base. The height is 7 more than that base. Okay, the area of the triangle is 60. Find the base and height. Well, that looks like fun. So we know the area. So A equals 1/2 base times height. A equals, oops, sorry, we already know the A. The A is 60. 60 equals 1/5 B plus 7 times B. Gosh, this is going to get fun. Okay, so I'm going to go ahead and multiply, so I'm going to divide both sides by half. So I'm going to, do I want to get rid of this? I'm going to get rid of this. So divide by 0.5. Divide by 0.5. 60 divided by 0.5 is different than what you think. It's 120. So now I'm going to distribute that to make this b squared plus 7b. Okay, I am going to subtract my 120. Oh wow, we're going back in the day now. So 0 equals b squared plus 7b minus 120. And then if you can remember, you multiply these two together. Oh my goodness. This guy comes up front. This guy's at the end. What factors of 120 when added equals 7b? I'll give you a hint. It is 8 and 15. So it's negative, so one of them has to be a positive. So I'm going to say positive 15b and a negative 8b. Then we do groupings. Oh my gosh, this is what we're doing in algebra. Almost done. B goes into both. Negative.
Chapin, please stop by the office. Megan Chapin, please stop by the office.
So this becomes b plus 15. This we're taking out the negative 8, negative 8, b plus 15. My gosh, we're almost done. B minus 8, b plus 15 is our final answer. Holy moly. Good luck with that one. It's been a while.